Hi, this is Mrs. Yamamoto, and today we're going to be talking about scientific notation. To talk about scientific notation, first I want you to think about the planet Earth. If we have the planet Earth, how much does this weigh? Weight of planets is referred to in mass. So the mass of Earth is going to be this many kilograms. So this is a very large number, and scientists use scientific notation to represent very large numbers in different ways. So the way that scientists use scientific notation is they start with the base of 10. 10 to the power of 0 is equal to 1. So think of it as there's a 0 exponent, so there's 0 zeros. 10 to the power of 1 is equal to 10. There's 1 exponent, so we have 1 0. 10 to the power of 2, or 10 squared, is the same as 10 times 10, which is equal to 100, so 2 zeros. 10 to the power of 3 is equal to 10 times 10 times 10, which is equal to 1,000, or 3 zeros. A side note, an interesting fact is 10 to the power of 100 by definition is called a googol. And you might be wondering, why am I writing googol like that? Well, before Google, as we know, was around, the definition of 10 to the power 100 was called a googol, and it was spelled G-O-O-G-O-L. So googol, G-O-O-G-L-E, as we know, is actually rearranging the way that this is spelled and calling themselves googol, which is 10 to the power of 100, which we know would be 1 with 100 zeros. So if I wanted to write this, it probably wouldn't fit on the page, but I could write 100 zeros. So using the idea with multiples of 10, we're going to figure out how I can write the mass of planet Earth in scientific notation. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So let's say I put my decimal point, my new decimal point, right over here. In scientific notation, I now have 5,972 times 10 to the 21st power. But what scientists like, and how we represent scientific notation, is this part right here, which is essentially considered our coefficient. We like this to be between 1 and 10. So the way we get that between 1 and 10 is I'm going to move the decimal point 22, 23, 24 times. So my new decimal point is going to be between the 5 and the 9. And this way, my coefficient is 5 and 972 thousandths times 10 to the 24th power. And again, I get the 24 by starting here and moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So with scientific notation, our coefficient is always represented as a number between 1 and 10 times 10 to the, and then something power. So here is our mass or weight of planet Earth in scientific notation. Let's go ahead and fill out some guided notes and talk more about scientific notation. So let's talk about standard form and scientific notation. So standard form would be the mass of planet Earth not written in scientific notation. So that would be 5972 with all of those zeros. So that's standard form. Scientific notation, on the other hand, is where we wrote it as 5 and 972 thousandths times 10 to the 24th power. Let's first talk about numbers in standard form. Standard form of numbers is a way of writing numbers using digits. And standard form sometimes has large numbers or small numbers. So let's say we're talking about a large number in standard form. In this case, the mass of planet Earth would be a really large number. So it is a number that is greater than 1. For example, let's say we have 765,389,000. The decimal point, remember, is at the end. And here's our decimal point. And it is invisible. We don't see it, but we know that the decimal point is there. Small numbers, on the other hand, by definition, we're going to define those as less than 1. A small number, for example, would be the decimal point 0.004785. And here, the decimal is at the beginning. And with numbers that are less than 1, when written as a decimal, we do see the decimal point there at the beginning. So just a brief note that large numbers, usually they have commas, and small numbers don't have the commas. So numbers in scientific notation. Very large and very small numbers are often best represented using scientific notation. So a number in scientific notation is actually the product of two factors. The first factor is greater than 1 and less than 10. And it's represented as a decimal. This means that there can only be one digit in front of the decimal. So if you think back to our mass of planet Earth, we initially wrote it as 5,972 times 10 to the 21st power, but in scientific notation we want the first factor, and the first factor is this portion here. We want this to be between 1 and 10. So that's why we put the decimal point. Instead of here at the end after the 2, we're going to put it between the 5 and the 9. And it was now to the 24th power. So the second factor is what we call a power of 10. So let's look at some numbers in scientific notation. So a power of 10 has a positive exponent, but it can also, in small numbers, have negative exponents. So a few examples would be 5 and 7/10 times 10 to the 4th power. That's an example of a number in scientific notation that has positive exponents, and here a number in scientific notation that has negative exponents, 3 and 42/100 times 10 to the negative 3rd power. So on this page, we're going to convert numbers from standard form to scientific notation. So Large numbers, they will have a positive exponent. So this is 863,700. So this is a large number we're going to write in scientific notation. We're going to move the decimal point to the left. So it shows a number between 1 and 10. So here is my decimal point. I'm going to move it to the left until it gets to a number between 1 and 10. So I have 1, 2, 3, 4, 5. So I move the decimal point 5 times. If I move the decimal point 5 times, that means I'm going to have an exponent of 5. And that decimal point is now between the 8 and the 6. So remember, to find the power of 10, you count the number of decimal places you move the point. So I move the decimal point 5 times, so that gives me a power of 5. Remember, the decimal point has moved to the left. The exponent will be positive. Now let's look at a smaller number. Smaller numbers are going to have a negative exponent. So I'm going to move the decimal point to the right until I get to a number between 1 and 10. So my decimal point is here. So I'm going to move it to the right 1, 2, 3 times. So I'm going to stop here because now I have 4.53. And that's going to be times 10 to the, so to find the power, which is what I'm trying to figure out, the power of 10, I'm going to count the decimal places I moved the point. So I move the point 3 times. So that means my decimal point is, my power is going to be to the negative 3rd power. So the decimal point has moved to the right. The exponent is going to be negative. And remember, the exponent isn't the number of zeros. It represents how many place value spaces the decimal was moved. So now we're going to go in the opposite direction. Now we have numbers in scientific notation that we want to convert to standard form. So the decimal point is going to be our starting point. So we always start where the decimal is. And the exponent, or that power, it tells us how many places and which way we move the decimal point. So if I have a positive exponent, I'm going to have a very large number. So here I have 3.5, or 3 5/10 times 10 to the 6th power. So I'm going to move the decimal to the right. How many times? Well, I have to use the exponent to determine the number of spaces I'm going to move. So let's go ahead and look at our exponent. We have an exponent of 6. So I'm going to move the exponent 6 times to the right. So I have 1, 2, 3, 4, 5, and 6. So this is where my new decimal point is. I'm going to fill in the spaces with zeros. So then my result is going to be a large number, and this number is going to be, let's see what I get. So I have 3 and 5, and 1, 2, 3, 4, 5 zeros, and when I place my commas, looks like I have 3,500,000. So our last example is going to now be converting a smaller number in scientific notation to standard form. So my exponent in this case is negative. A negative exponent will be a small number. So I'm going to move the decimal point to the left, and I'm going to use the exponent my exponent of -5 to determine the number of spaces to move. So let's go ahead and move that exponent to the left 5 spaces because I have an exponent of -5. So 1, 2, 3, 4, and 5. So I'm going to fill in the spaces with zeros. And my result is going to be a small number. So let's see what my number is here. Here's my decimal point. And my number is 0.0000724. All right, nice work. To learn more about scientific notation, go to brainpop.com, and for the username, type El Rancho MS, and the password is BrainPop. And take a moment and watch the BrainPop video about scientific notation. We're also going to watch this tomorrow in class. Have a good day.